Today I'm gonna teach you exercise number 2.5 differentiation. Question number 11. Number 11 is show that dy by dx is equal to y by x if y by x is equal to tan inverse of x by y. This tan is tan inverse of, there is no bracket in question, but we put a bracket for our own easiness, that we consider this term as theta. Now we take this term, we will start our question from this and we will end at this. Basically we want to show that dy by dx is equal to y by x. So this is our question and we want to prove this. Y by x is equal to tan inverse of x by y. First of all, what we will do, y is equal to, this term we will take in the right side, so divided term will become multiplied term on the right side, tan inverse of x by y. Derivative of y with respect to x. So here variable is x, so differentiate with respect to x. Dy by dx is equal to d by dx x into tan inverse of x by y, and this we term as u and this we consider, this we take it as u and this term we take as v. So basically we want to differentiate of product of two variable u into v. Now u derivative of v is tan inverse of x by y. Now plus v derivative of u plus u derivative of v plus v derivative of u is x. Now x has the derivative of tan inverse of x. As you know that derivative of tan inverse of x is equal to 1 by 1 plus x square. So this is our x, so 1 by 1 plus x is x by y square. So now 1 by 1 plus x square, we see that this is not simple x, so we'll again differentiate x by y. Both these are variable, x is also variable and y is also variable. Plus tan inverse of x by y. Derivative of x with respect to x is 1. Now x divided by 1 plus x square by y square. Now we can see that there are two variable and the quotient of two variable, derivative of quotient of two variable is, this term we consider as u and this term as v. So v is y, derivative of u is x, minus u derivative of v is y, whole divided by v square, v is y square, plus tan inverse of x by y. Next is equal to x by, we'll take LCM, y square divided by 1 by, y square is divided by 1, but we get y square is multiplied by 1 y square. Denominator is divided by denominator and the answer what we get is multiplied by numerator, plus similarly denominator is divided by denominator, y square divided by y square, but we get 1, so x square into 1 becomes x square. Now y derivative of x with respect to x is 1 minus x dy by dx as it is whole divided by y square plus tan inverse of x by y. This y square and this y square cancel each other. Now x by y square plus x square into y minus x dy by dx plus tan inverse of x by y. Now x is multiplied by y, xy divided by y square plus x square, which is equal to x into y divided by x square plus y square. Y square plus x square, yeah, or x square plus y square, same thing. Xy we write this term. Now x minus x into x square divided by y square plus x square and dy by dx. So minus x square by y square plus x square dy by dx and plus tan inverse of x by y. This is dy by dx minus x square divided by y square plus x square into dy by dx plus tan inverse of xy as it is, so plus tan inverse of yx as it is. Now this is dy by dx and this is dy, so we will take in the left side minus sign become positive sign plus x square divided by xy square plus x square dy by dx. What is left? Xy divided by x square plus y square plus tan inverse of x by y. Now dy by dx will take common 1 here 1 plus x square by x square plus y square. Now xy by x square plus y square. Tan inverse of x by y, this is tan, this we named as equation 1. Tan inverse of x by is equal to y by x. So we'll write tan inverse of x by y by x, and here we write because we are using equation 1. Further, what we will do, we'll take LCM dy by dx as it is and LCM x square plus y square. Now x square plus y square divided by 1, what we get? X square plus y square and multiply by 1 x square plus y square plus x square is equal to, both these terms will take LCM x into x square plus y. This term is divided by this term, but we get this and this cancel, x is left. So x is multiplied by x into xy x square y plus this term is divided by this term, this and this term cancel, this is left. So this term is multiplied by y. So x square plus y square is multiplied by y. Denominator is divided by denominator. When we divide, x and x cancel, this is left. And the answer getting is multiplied by numerator. This term we get and is multiplied by numerator. Numerator is y. Now dy by dx as it is, x square plus x square become 2x square plus y square divided by x square plus y square. Now x square y plus x square y and x square y plus y cube divided by x into x square plus y square. Now this x square plus x square becomes 2x square y plus y cube as it is, x into x square plus y square. Next we can see that y is common, so y is common, 2x square plus y square. 1y is common. Here 1y is common, so y square is left. By x square plus y square. Now here we put dy by dx 2x square plus y square divided by x square plus y square. Dy by dx 2x square plus y square divided by x square plus y square. Now we can see that both these equations are same. This term and this term are same, or this term is multiply. Here this term is multiply. Y by x 2x square by y square divided by x square plus y square. Now this term is multiply this term, and when we take in the right side, multiplied term will be divided, and this term is divided. When taken the right side, divided term will be multiply. Here dy by dx is left. We take this term in the right side. How to take? Multiplied term will be divided and divided term will be multiplied. Now we can see that x square plus y square is same as x square plus y square. 2x square plus y 2x square plus y square and 2x square plus y square cancel each other. What is left? Y by x. So dy by dx is equal to y by x. So this gonna proved. This is our solution, because we want to prove that, show that dy by dx is equal to y by x, and we show that dy by dx is equal to y by x.